Hello, my name is John Slater. I'm the CEO of Digiskool. With me and my team, Gakobo, who is a robotics and electronic engineer, Dan, who is a software developer. We've come up with a product called Digiskool Kids, which is a robotics and programming course for kids. So you might wonder that how do you teach 6-year-olds about robotics? We do it through in a very fun and interactive way. Every kid wants a toy and wants a remote controlled car. You as a parent, you know how pricey that is. So we start very early by teaching them programming skills. Kids don't really need to know about what's going on here. All they want to do is to learn, does it move forward? Does it come back? Does it do that? And to do that, then we have the electronic aspect. We have the physical aspect, which is called the hardware, whereby it's like this car, there is a wheel, there are motors, there is a board, there is battery, then there is a remote, the normal TV remote to control the car. Then there is the software bit. So how does this car know how should I go forward? If I press this key, should I come back when I press this? That's the robotics bit. So how we do the robotics for kids, we have an interactive platform called Scratch and MBlock, which is block-based programming, whereby it's just like a Lego. They just put blocks together and they're able to create functional code. Like for this robot, we tell it to go forward, we tell it stop, tell it come back, stop. So that's just a code which say, if I press this key, go forward. If I press this key, stop. If I press that, so programming is just sequential steps of instructions which you give to a computer. So we do this from age 6 to 17 with it increases in complexity. But for small kids, we just show them fun stuff, a robot that can stop, can go, can do this, and even physical interactive robots which can walk. So we make it very fun for kids. So as they're playing, what they're realizing, they're learning these STEM skills: science, technology, engineering, mathematics. Like the code which says move 2 steps forward. It's just you're adding 1 + 1, move 2 steps. So arithmetics, mathematics skills. So in a very fun and interactive way. Our instructors are trained to make it fun as possible for the kids and follow up and make it fun that they can, something that will stick. So imagine instead of buying your child a robot or a toy car, an RC car, or a helicopter car, your 10-year-old will be able to make that one day. So what we are looking into the future is a very bright future. So these things that we're trying to introduce in Kenya are things which are already happening in China, in Japan, in America. 10-year-olds are already doing this. So the same kind of technology that they're doing, we want them to be able to do it here and change this country. Thank you. So my colleague Dan will take you through, this is the physical aspect, how it's working, but now the software bits will take you how it's happening. Then David, the electronics engineer, will also take you about the components in a very high level form, so that don't worry about the wires. This shows that it's not something we bought. It was built by hand, every single bit, so that you as a parent can see this. So we welcome you to Digiskool Kids. We have an open day. Please come, see, make it fun. We are partnering with schools. We are doing also for individual classes. Your daughter, your son, from 6 years old to 17 years old. We have a program for each one of them. Karibu.
This is Scratch. Scratch is a program where you are going to be writing the logic for running our toy car. For example, if you want the car to move forward, to move backwards, to stop, to make a sound, all that, we are going to do it from Scratch. So the first thing you're going to do, because you're going to make a toy car to move forward and backwards, we're going to select a toy car. So we're going to remove this one. This is a cut. You're going to remove the cut. We don't need a cut here. So delete the cut. You come here, choose a sprite. Then you come here and select sprite car. So you can choose a car you want here. I want convertible. You can see our car is here. So we're going to make this car to move forward and backwards, then to make a sound. I want to change the color of my car to a different color. Let's say I want to make it blue. The file come under costumes. I will select my paint. I can select paint here. Then I can select here, choose color blue, and paint my car here. So you can see how simple it is even for 6 years old. They can enjoy playing with the colors as they're coloring their car. So I think that's good for us. So then we click on code back. So what you want to do, we want to make this car to move forward and backward. So what do? When I click on this car, I want it to move forward, then backward. I come under events. So the name of this car is called Sprite. There it is. When the sprite is clicked, you can see this is block-based programming. It's like Lego blocks, where you just join blocks. For example, you can see this is let me show you another thing. You can see that this one will enter here. It's like Lego blocks. So, for example, here when I click this car, it will move 10 steps. Then, so this says move 10 steps. The car will move 10 steps. Then I want it to stop for some minute, like 2 seconds. So I come under control. The control, then I click on wait. I drag wait, I drop it here. I want it to wait for 2 seconds. Click on the inside there, put 2 on the keypad. Then I want it to move again back 10 steps. So I click there. 10 steps. Okay. Then after this, I want the car to make a sound. I want it to beep or to pop. I click on sound here. Then you can choose what you want here. There's play sound until done. What it means that it will play the sound until the whole sound is complete. But I just want to start a sound, pop. So this logic says that when I click on this car, it will move 10 steps. Then it will wait 2 seconds. Then it will move back. Then it will play a sound. So we're going to test it now. Okay. So we have made a block here. We have been dragging and dropping. We've dragged different blocks. So the first block says when I click on this sprite, I want it to move 200 steps. So it will go forward 200 steps. Our car will move 412 steps. Then we'll wait for 2 seconds at this position. Then we go back. Our car will go back. Our toy car will go back 200 steps again. Then it will wait for 1 second. Then play a sound. So this is simple block programming, and we are going to demonstrate it now. So when I click on the car, it moves forward, then waits 2 seconds, it moves back, then plays sounds after 1 second. So this is how simple block programming is. It is simple, drag and drop. All the explanations and the logic are on the cards. For example, move, turn to the right, turn to the left, go to position, point to direction, change X by sound, play sound. You can select a sound or record your own sound. So these are the different logics you can just drag and drop. That's how simple it is. You don't have to learn anything. Even a 6-year-old child can learn this thing under a few days and be able to be very productive in coding such logics for the car.
Hello. So I know most of you are wondering how the electrical car technology have come to be. So with me here is a simple model, one like those being used by Tesla to make these electrical cars which have hit the market right now. So I want to take you through what we need, the components of this car. So we have an Arduino board. This is our brain. It's here. You can see it here. It's called the brain of this car, which interprets all signals and commands the car to move. Probably, let's say it's moving forward or backwards. Then we have our battery. It's the source of power which powers our car. Then we have the motors. Motors are the one which transmits the motion. It converts the electrical energy from our batteries here to motion. Then we have our receiver. Here is our receiver. this receiver receives the signals from a remote, normal remote, a TV remote, like the one with me. Then we have the motor controller. So it's this simple circuit here. It controls the motor to move forward or backwards. Then we have the wheels. These are the wheels with me here. So they are just like, it's just like a normal car, as you can see it. It's only for a few bits of technical part of it where you can see these wires, but this shows us that we've made this car manually. So our kids can do this, and if you want your kid to be the next Tesla big gigantic company, you got us. Thank you very much.